Hello everyone, welcome to NG Classes YouTube channel for a video lecture series on signals and systems. In this video we'll consider the concept of energy and power signals, and in that we'll consider one simple numerical, and the task is to determine is this signal energy or power, and later we need to find its respective energy or power. So the given signal x of n is equal to 2 to the power n u of minus n. So the task is it energy or power signal? So how do I determine that? First thing is, my first question to you is it continuous time signal or discrete time signal? So that should come to your mind and try to sketch the signal, then we can comment about its energy and power. Yes. What is the answer? Is it continuous time signal or discrete time signal? So one can clearly say it is discrete time signal. Why? Because it has been expressed as in terms of x of n, 2 to the power n u of minus n. So x of t is continuous time, rather x of n is discrete time signal. Based on that I can say it is discrete time signal first of all. Next thing is, what is that? It is 2 to the power n u of minus n. What the signal is? It is a product of two signals. One is 2 to the power n, another is u of minus n. Later I need to multiply them. So first, the very first task is I need to sketch these signals. So how do I sketch these signals? Let me start with that. First I'll sketch 2 to the power n. Later I also sketch u of minus n, and I will multiply them. So that's why I'm drawing uh, the graph over here. This will be 2 to the power n, this will be u of minus n. Ultimately I'll get the product signal. Are you getting what I'm saying? So this is, I'll draw a little bit on negative side as well, because that is also important for us. Okay, so now first let me sketch 2 to the power n. So this signal I call it as 2 to the power n with respect to n. So n takes the values, discrete values, that is 0, 1, 2, 3, 4 and so on, and it takes negative as values as well, that is minus 1, minus 2 and so on. Let me check. If I put n equal to 0, the signal is 2 to the power n. 2 to the power n. 2 to the power 0 is nothing but I'm going to get 1 over here. Is that okay? So now I'll put n equal to 1. 2 to the power 1 is nothing but 2. That is the value at n equal to 1. Similarly, I'll put n equal to 2. 2 to the power 2. What I'm going to get? I'm going to get 4 as the answer. So this signal I call it as 4. This is 2. This is 1. Similarly, I'll put n equal to 3. I'm going to get 2 to the power 3. That is nothing but 8. Are you following? In this way it continues. Similarly, I can get negative values as well. Put n equal to minus 1. What I'm going to get? 2 to the power minus 1 is nothing but 1 by 2. So I'm going to get 1 by 2. And if I put n equal to minus 2, it becomes 2 to the power minus 2 is nothing but 1 by 4. And so on. In the similar way, this continues. Are you understanding what I have written? Next, let me also draw u of minus n with respect to n. So what will be u of minus n? First I should know what is u of n. U of n is nothing but unit step signal. U of minus n is nothing but its a reflected version. So how does that look? We already know how does u of n looks like. So take the reflected version of that. It looks something like this. Is that okay? With amplitude 1 everywhere. This is 0, minus 1, minus 2, minus 3 and so on. The task is I need to multiply these two things, and ultimately I'm going to get x of n, that is nothing but 2 to the power n u of minus n. So if I multiply them, what I'm going to get? So consider on to the LHS, I mean the positive sides. Here 2 to the power n exists, but I don't have anything for u of minus n. So ultimately I'm going to get all values as 0. For n equal to 1, 2, 3, I'm going to get the amplitude as 0. I hope you are following it. Similarly, let me see for the n equal to 0. This is 1 and this is 1. Both get multiplied, and ultimately I'm going to get 1 as the signal for n equal to 0. Similarly, I have to get n equal to minus 1, minus 2 and minus 3 as well. Let me check. For n equal to minus 1, the signal is 1. And this is 1 by 2. 1 by 2 into 1. I'm going to get 1 by 2. Are you understanding? Okay. Next, at n equal to minus 2, amplitude is 1, n equal to minus 2, amplitude is 1 by 4, 1 by 4 into 1. Anyone can say that it is again, this time it is 1 by 4. Am I correct? Yes. Similarly, n equal to minus 3, this is 1 again. N equal to minus 3, this would be 1 by 8. 1 by 8 into 1. Anyone can say that I said it is 1 by 8. I'm going to get, let me indicate that signal, 1 by 8. So this is the ultimate signal x of n with respect to n. So now I need to talk about this signal. Is it energy or power signal? Are you understanding? So by this point of time, everyone must be able to sketch this signal, then only you can talk about its energy and power. Are you getting what I'm saying? By this point of time, you should know how to sketch independent signals, and multiplied version of that, the ultimate signal, one should be able to sketch. Once we can do that, I can only now say is it energy or power signal. Yes, what would be the answer? Is it energy or power signal? That depends on, is it periodic or aperiodic? If the signal is going to be periodic, I would say that the signal is a power signal. If the signal is aperiodic or non-periodic, such signals are energy signals. That statement we earlier made, and based on that we come to the conclusion. Is it periodic or aperiodic? Anyone can say that it is a periodic signal. Why it is a periodic signal? Because there is no pattern over here which keeps repeating. The signal, moreover, the signal exists only from minus infinity till 0. 1 or 2 infinity, it does not exist, and there is no pattern at all that keeps repeating. Hence, I would say the given signal is periodic, aperiodic. Sorry, it's non-periodic. As it is aperiodic, the answer is it is energy signal. The given signal is energy signal. What could be the, what is the reason? Because I say it is energy signal as it is aperiodic in nature. Are you understanding? So my answer is, conclusion is, it is energy signal as it is aperiodic in nature. Once we have concluded that it is energy signal, the very next task is to find its respective energy. So how do you find the energy? We have the ready formula for that. E equal to summation n equal to minus infinity till infinity x of n square. So get the summation and we can get the energy, we can find the energy. So now with respect to our given numerical, I have to vary the limit. Lower limit, it still stands at minus infinity. What would be the upper limit? The signal stops at 0. From 1 onwards, I don't get anything. Hence, the limit would be minus infinity to 0. Are you following with me? Then, x square of n. What is x square of n? It is nothing but 2 to the power n. U of minus n in that region, it is 1. So, ultimately, the signal is 2 to the power n. I need to square this. Is that okay? So what I do now is I'll just take that 2 inside. I'll let the limit be as they are, minus infinity to 0. I'll take 2 inside. It becomes 4 to the power n. Is that okay? So next thing is, in the limits for the summation, I have minus infinity. But there is one geometric series, ready geometric series, which we have learned from high school, which says that summation n equal to 0 to infinity alpha to the power n is equal to 1 divided by alpha. Do you remember this formula? So if I want to make use this formula, just see the changes. I have to make the proper arrangements over here. The limit is minus infinity. I mean, one of the signs is minus, but here I don't have anything negative. So this must also be positive. So how do I make it positive? For that, I'll change the variable. I'll say put n equal to minus m. So let's see what happens. If I put n equal to minus m, the limits are going to be positive. Is that? Let me check. I said n equal to minus m. So here m equal to n equal to minus infinity. So I'll get minus infinity equal to minus m. So minus and minus would cancel. I will get m equal to infinity at the lower limit. What would be the upper limit? N equal to 0. Put 0 over here. I'll get 0 equal to minus m. So m is going to be 0. There is no difference between plus 0 and minus 0. So I'll give it as 0. 4 to the power. So what is n now? We have put n equal to minus m. So it becomes minus m. Very simple. So next, summation m equal to, what can I write here? It is infinity to 0. Can I write it as 0 to infinity? Yes, I can write it. If as it is a summation, I can interchange the limits, upper limit and lower limit of a summation. I can change it without adding any negative sign. Instead of, if it is an integration, then if I want to change the limits, I must include a negative sign. As it is not the case, I have only summation over here, I can interchange the limits without any negative sign. Is that okay? So then it is 4 to the power minus m. Can I take minus 1 inside? So I'll write 4 to the power minus 1 whole to the power m. So why I'm doing like this? There must be a reason. So what is that? Let me see that. Summation m equal to 0 to infinity. It is 4 to the power minus 1 is nothing but 1 by 4 to the power m. So I said if I want to make use of this geometric series, alpha must be less than 1. So now because of that I changed it. I got it alpha as 1 by 4, which is less than 1. Therefore I can make use of the geometric series. So making use of geometric series, I can find the answer. Energy E is equal to, it is 1 divided by 1 minus alpha. So compare the terms, all are very much similar with respect to this formula, and in place of alpha I have 1 by 4. Therefore that becomes 1 divided by 1 minus 4. Is that okay? So it is 1 divided by, take the LCM, 4 minus 1, it is 3 divided by 4, and if I can get the final answer, E is equal to 4 divided by 3 joules finally. So this is the energy of the given signal. Is that okay? What we have discussed? There is a lot of concept of signals and systems until this point of time. Once we have done, the next is only the simple mathematics. So it is, I would say 20% of signals and systems concept and 80% of pure mathematics. So those who are good at mathematics, one can solve it very easily. Even though if you feel you're not that good, with this concept, one can understand and solve any numericals on these kind of numericals. Is that okay? So if there are any doubts, please let me know them in the comment section and I will definitely answer those doubts. Meanwhile, subscribe to our channel NG Classes for more videos on the concept of signals and systems. Thank you everyone for watching.